Hello everyone, welcome to Learning Management System, Department of Collegiate and Technical Education. Myself, Sridhar Murthy, Selection Grade Lecturer, Department of Electrical and Electronics Engineering, Government Polytechnic, Chikmagaluru. Today, we are going to learn about the principle of operation of alternator, session number 28 of Unit 4 belongs to DC machines and alternator subject, third semester. So before going to the session number 28, let us try to recall what we have learned in the previous session, that is in session number 27. In session number 27, we have learned about the introduction to alternators of same unit number 4. In that introduction to alternators, we have learned the definition of alternator, the important points regarding the alternator, and the major difference between a DC generator and an alternator. So these are the topics that we have learned in the previous session. In today's session, we are going to learn about the principle of operation of alternator. So in the previous session, we have learned the definition of the alternator, the points related to alternator, and the difference between an alternator and DC generator. And today we are going to learn about the principle of operation of alternator. Students, as we have discussed in the previous session, and the basic definition of alternator is that it is a electromechanical device which converts mechanical energy into electrical energy in the form of AC. Not only that, similar to DC generator, an alternator also works on Faraday's laws of electromagnetic induction. So this is the basic principle of operation of an alternator. So both alternator and DC generator works on the same basic principles of electromagnetic, Faraday's laws of electromagnetic induction. So again, recalling the definition of alternator. So then the principle of operation of alternator. So in this session, we are going to learn mainly on the principle of operation of alternator. So quickly, we will recall the definition of alternator. So alternator is a machine, is a electromechanical machine which takes mechanical energy at the input and gives out the electrical energy in the form of AC. So this is the definition of alternator. Alternator is an electromechanical device that converts mechanical energy into electrical energy, and that electrical energy is in the form of AC. So this is what we have learned in the previous. So this is just before going to understand the principle of operation of alternator. So this is the definition. Next, as I told you, the working principle of alternator is just like the basic principle of DC generator. So regarding the principle of operation, there is no much difference between the alternator and the DC generator. So as I told you, alternator also works on the Faraday's laws of electromagnetic induction, which says that what is the law of Faraday's laws of electromagnetic induction? Whenever the flux linking with the conductor changes, the EMF is induced in that conductor. That means when there is a flux linkage changes with the conductor, an EMF is induced in the conductor. We can state this law as whenever a conductor cuts the magnetic lines of force, an EMF will be induced in it. So this is the uh, law of Faraday's laws of electromagnetic induction. So which means that a current or a voltage is induced in a conductor when there is a relative motion between the conductor and the magnetic field. So this point is very important. There must be a relative motion. So then what is meant by the relative motion? That means if both conductor and magnetic field are rotating with the same speed, there is no relative motion. When there is no relative motion, no flux linkage, there is no change in flux linkage with the conductor. Hence, no EMF will be induced in the conductor. So there must be a relative motion. That means either of the conductor or magnetic field must be stationary and the another one should be rotating. Or if both are rotating, there must be a difference in speed. So hence, there should be a relative motion between the conductor and the magnetic field. So this is the basic principle of operation of alternator. Okay. So whenever the flux linking with the conductor changes, an EMF will be induced in that conductor. And for this, there should be a relative motion between the conductor and the magnetic field. Next, coming to the understanding the detailed principle of operation of alternator. So let us consider, as shown in the figure, let us consider a rectangular coil. See, consider a rectangular coil which is connected to a handle. That means this rectangular coil is made to rotate in a uniform magnetic field, North Pole and South Pole, which is a uniform magnetic field. Okay. This turn or a coil is having two sides. One side is connected to one slip ring and another side is connected to another slip ring. That means the voltage or the current induced in the sides of the coil are conveyed to the two slip rings, and from the slip rings, the current will be connected to the external source or the circuit through carbon brushes. So this is the arrangement, which is nothing but a simple loop generator that what we have discussed in understanding the principle of operation of DC generator in unit number 1. So the same thing we are repeating once again here also, because regarding the principle of operation, there is no much difference between an alternator and a DC generator. But in case of a DC generator, we have a commutator, but in case of an alternator, there is no commutator or split rings. Okay. Now, so this is the arrangement of a simple loop generator. That means a single rectangular coil is made to rotate in a uniform magnetic field as shown in the figure, and one side of the coil is connected to a slip ring, another side is connected to other slip rings, and on these two slip rings, two carbon brushes have been placed. So this is the arrangement. That means the two sides are nothing but AB and BC. So this coil is made to rotate against axis AB. So this is the dotted line which will shows the axis of rotation. And here the coil is assumed to be rotating in clockwise direction. It is assumed to be rotating in clockwise direction. Okay. So that is the explanation that what we have discussed just now. That is for understanding of the working of an alternator. Let us think about a single rectangular turn placed between two opposite magnetic poles as shown in the above. Okay. Now what happens? See, this single rectangular coil, what we have seen in this diagram, is made to rotate in clockwise direction in a uniform magnetic field. So this is the initial position. In the initial position, that means the turn or the coil is about to rotate in clockwise direction, is about to rotate. That means it is yet to start to rotate. That means right now it is not rotating. Hence, no EMF will be induced in the turn or the coil because the coil is not moving. Now coming to this diagram, the coil has rotated through an angle of 90 degree. So this is the 0 degree. Here the coil has rotated through an angle of 90 degree in clockwise direction. In clockwise direction. That means the coil AB comes opposite to the pole S, whereas the coil side CD is under the influence of N pole. So the coil has rotated through an angle of 90 degree from its zero position. So this arrow mark indicates the direction of rotation. See, initially, initially when the coils start to move, initially the coil sides are parallel moving parallel to the magnetic field. Then it becomes then it becomes perpendicular. That means initially the coils are moving parallel, then it becomes perpendicular. Hence initially zero EMF is induced, and finally when the coil moves perpendicular, it cuts a maximum flux. Hence maximum EMF will be induced in the coil side AB and CD. So that means in this diagram the maximum EMF will be induced in this position. Now by using Fleming's right hand rule, we can identify the direction of the current induced in these coil sides. See, here, the Fleming's right in the Fleming's right hand rule, the thumb should be pointing downwards here because the coil AB is moving downward, the coil CD is moving upward. So by applying Fleming's right hand rule, thumb is in the downward direction and forefinger is in the direction of the magnetic field as shown in the blue line. Okay, direction of the flux. Then the middle finger will gives you the direction of induced EMF, which is coming towards the observer, which is as shown in the red arrow mark. So hence, similarly, applying the Fleming's right-hand rule again to this coil side CD, we find the direction of induced EMF flowing away from the observer, flowing away from the observer. Hence, finally, we can point out the direction of the induced EMF is from A to B to the slip ring and then to the other slip ring and from C to D. Okay, so finally, the direction of the induced EMF we can point out is from C to D, A to B, slip ring, and the external circuit. Okay. Now remember, in coil AB, in coil side AB, the induced EMF is coming towards the observer. Okay. So that is what explained in this uh, literature. Okay. Now let us consider the coil has moved further through an angle of 90 degree or 180 degree from the initial position. So that means here the zero position, now the coil has rotated through an angle of 90 degree and here the coil has rotated further 90 degree or 180 degree. Okay. Now in this position, initially, that means in this position, initially this coil side moves perpendicular. Initially the coil side AB and CD moves perpendicular, but then become parallel. That means what happens? Initially, maximum EMF will be induced, but later on, when the coil moves parallel to the magnetic flux, zero EMF will be induced. That means coil in the coil side, AB and CD, initially the maximum EMF will be induced and finally the induced EMF becomes zero. That means this coil side has come to the original vertical position. So zero EMF will be induced. Half cycle of rotation has been completed. Half cycle of rotation is completed. Okay. Now in this position, zero EMF will be induced. Okay. Observe, no direction of the EMF is shown in coil CD and AB. Zero EMF will be induced. Now let us consider. Now let us consider another diagram. Now let us consider another diagram where the coil has further moved 90 degree from the previous diagram or 270 degree from the initial position. Now what happens? The coil CD, now observe here, the coil CD is now under the influence of S, whereas coil AB is under the influence of N. So this is, now compare that diagram with this. So in this diagram, the coil side AB is under the influence of S pole. Coil side CD is under the influence of N pole. And also note down, in coil side AB, induced EMF is coming towards the observer. Okay. Now, in this diagram, observe carefully. Now in this diagram, coils, coil sides CD and AB have interchanged their positions. Now, previously, coil side AB, which is under the influence of S pole, now goes to the influence of N pole. Whereas CD, previously under the influence of N pole, now comes under the influence of S pole. Now, previously, in coil side CD, the current is moving away from the observer. Now, in coil side CD, the current is, or the induced EMF is moving towards the observer. That means in this diagram, the induced EMF has changed its direction. Okay, has changed its direction. So, which is found from, again, Fleming's right hand rule, which is found to be from B to A to D, D to C, and then to the slip ring and to the external circuit. So that means comparing to the 90-degree position and 270-degree position, maximum EMF will be induced, but both are in opposite direction. So in this position, initially the coil sides are moving parallel, then it become perpendicular, hence maximum EMF will be induced. But students, note down here, maximum EMF will be induced, but in the opposite direction to that of position 90-degree. Okay. So now again consider, the coil has been moved further 90-degree or 360-degree from the initial position. That means the coil comes to the original position. The coil comes to the original position as shown here. After 270-degree, if the coil is further moved to an angle of 360-degree, then it comes to the original position. That means induced EMF will reduce us from its maximum position to zero position. So finally, one cycle of rotation has been completed by the coil. So that means, so one cycle of EMF will be induced in this coil. So students, that's what mentioned here. While the turn further proceed to its vertical position, the current is again reduced to zero. That is from 270-degree back to 0-degree. Okay. So if the turn continues to rotate like this, so the current in the coil will also continues to alternate its directions. Okay, alternate its direction. Here, point is noted that one, when the coil completes its one cycle of rotation, that is from 0-degree to 360-degree, one cycle of EMF will be induced. That means for one cycle of EMF induced, then the coil has to rotate through a pair of pole. Okay. So in order to induce one cycle of EMF, a pair of poles very essential. That is the outcome of this discussion. Okay. Which is very important to derive the EMF equation of alternator. Okay. So that is what mentioned over here. Okay. So in turn gradually reaches to its maximum value, then reduces to zero. That means, see here, if the turn continues to rotate, the current in turn continuously alternate in its direction. During every full revolution of the turn, the current in turn gradually reaches to its maximum value, then reduces to zero, then again comes to maximum, again reduces to zero. That means the EMF increases from its zero, reaches its maximum value in one direction, reduces to zero, for again increases to maximum value, but in the opposite direction, again comes back to its 0-degree. Okay, comes back to it zero value or in 360-degree. Okay. Now, so finally, we have seen how alternating current is produced if a turn is rotated inside a magnetic field. So that means from this discussion, from the assumptions of The simple loop generator, we can understand when a coil is rotated in a magnetic field, the EMF is induced and that is alternating in nature. So this is the basic principle of operation of an alternator. So in general, in practical, the alternator is not like as simple loop generator. Simple loop generator is just a device used to understand the basic principle of operation of alternator. But in practical, but in practice, an alternator consists of large number of conductors and it is often a bigger size. Okay. Next, if you plot the variation of this induced EMF in the coil with respect to the time. Okay. So with respect to the time, if we plot the variation of the voltage in a coil, then the coil, in the coil, the EMF increases from its zero, reaches to its maximum value, that is point A, in the first quarter. First quarter means 90 degree of rotation. In the second quarter, 180-degree rotation. The EMF induced reduces from its maximum value to its zero value. Again, in the third quarter, that is from 180 degree to 270 degree. Again, the induced EMF increases from its zero value to its maximum value, that is point number C, but in the opposite direction. This is plus E maximum, this is minus E maximum. Okay. After point C, if the coil is further rotated through an angle of 90 degree from this position, or initially from this initial position 360 degree, then the coil reaches, completes its one complete rotation, that is the fourth quarter, from 270 degree to 360 degree. The induced EMF will reduces from its maximum value to zero. So this is what a sine wave. The induced EMF in the conductors of the alternator is AC. So this is the principle of operation of alternator. Okay. Now after this, let us uh, see some of the multiple choice questions. Before that, let me to conclude once again. In this session, we have recalled the basic definition of an alternator, and we have discussed the basic principle of operation of alternator, that is with the help of a simple loop generator. This is how the alternator works. So regarding related to this session, we will have some questionnaires, that is a multiple choice questions. Question number one, alternator works on the principle of. So on what principle the alternator will works? Self and mutual induction, self mutual induction, Faraday's laws of electromagnetic induction, mutual induction. See which is the answer. So self or and mutual induction, no chance at all. Self mutual induction, never. Mutual induction, not the one. It works on Faraday's laws of electromagnetic induction, that is dynamically induced EMF. Instead of this Faraday's laws of electromagnetic induction, if the answer given is, if the choice is given as dynamically induced EMF, then the answer is dynamically induced EMF. So what's the answer? Answer C, Faraday's laws of electromagnetic induction. That is the right answer. Move on to the second question. A machine without commutator. Observe carefully. A machine without commutator providing an AC EMF to the external circuit is called as. That means, which is that machine which is supplying the induced voltage to the external circuit without the commutator. Try to understand the question properly. Without the commutator or without this split ring, which is that machine? The machine is, the options are DC generator, alternator, synchronous motor, transformer. Never DC generator, we need a commutator, synchronous motor. So still it is a motor. We are concentrating on induced EMF to the external circuit, means it must be a generator. Okay. So the last two choice are not related to this one. So only these two answers are related to this one because the question is relating to a generator. In these two question answers, we have to select either it is a DC generator or an alternator. So in DC generator, we are using the commutator. Hence, the final answer is alternator. Next, in a synchronous generator, one pole is responsible for. So for one pole, how much EMF is induced? Let us see. 90-degree electrical of induced EMF, 180-degree electrical of induced EMF, 360-degree electrical of induced EMF, 720 degree electrical of induced EMF. So one pole means half cycle. Half cycle means 180 degree. So for 360 degree, that means for one cycle of induced EMF, we need two poles. One pole for 180 degree, another pole for 180 degree. So both the poles including 360 degree. Suppose in this question, if it is asked as in a synchronous generator, one pair pole is responsible for what? 360 degree. But here the question is asked as for one pole. For one pole, the answer is 180 degree. Next. When we plot the magnitude of the induced EMF against the time, the nature of the induced EMF will be what type of induced, what is the nature of the induced EMF? Is it a sinusoidal? Is it a square, triangular, or a parabolic? No. As we have discussed in the last slide, previous slides, it is sinusoidal in nature. The answer is sinusoidal. Next question is, during the one complete revolution of the conductor in a four-pole synchronous generator, induced EMF will experience, observe, four-pole synchronous generator. During the one complete rotation, see, remember, for one single turn coil, completes a 360 degree of rotation, then we have a 360 degree. That means one cycle of EMF will be induced. Okay. So here, four pole synchronous generator. Here it is given four pole. For two pole, we will get one cycle of EMF induced. For four pole, let us see what is the option. 2 times maximum and 2 times 0. 2 times maximum and 4 times 0. 8 times maximum and 8 times 0. 4 times maximum and 4 times 0. Suppose, coming back to this question, one complete revolution of the conductor in a four-pole synchronous generator. Induced EMF will experience. See, if it is a two-pole machine, one cycle of EMF will be induced. In one cycle of EMF induced, we have two maximum, two zeros. Then what about the four-pole machine? Two cycle of EMF will be induced, obviously doubled, four maximum, four zeros. Then what is our answer? Four times maximum and four times zero. So this point is very important because remember, dear students, for one cycle of EMF to be induced in a conductor, we need a pair of pole. What is meant by a pair of pole? Two poles. Okay. Here it is asked as four pole. Then it is two cycles, two maximum, two zeros for one cycle. Then for two cycles, four maximum and four zeros. Four times maximum and four times zeros, the EMF will experience. Next question, question number 6. If the motion of the coil side is parallel to the magnetic flux, then that means if the coil side is moving parallel to the magnetic flux, then what happens? Maximum EMF will be induced, no EMF, minimum EMF, none of the above. So if the coil moves parallel, see, if this is the flux, okay, if this is the flux, if the coil moves initially parallel, that means it won't cut the flux. In order to cut the flux, the side of the coils must rotate in perpendicular direction. Okay, in perpendicular. When the coil moves perpendicular to the flux, then maximum EMF will be induced. But here quoted as if the motion of the coil side is parallel to the magnetic flux, then obviously no EMF will be induced in the conductor. Next question. If the conductor moves initially parallel, observe here. If the conductor moves initially parallel, then perpendicular to the magnetic flux, what happens? Options: EMF increases from 0 to maximum, decreases from maximum to become 0, no EMF will be induced, maximum EMF will be induced. See, observe here. Initially, the conductor moves parallel, no EMF or 0 EMF. Then it becomes perpendicular. When it moves perpendicular, maximum EMF will be induced. Maximum EMF will be induced here. That means, which is the option? EMF increases from 0 and becomes maximum. So answer is A. EMF increases from 0 and becomes maximum. So that's all. So these are the most likely questions in this session. So once again, I am recalling what we have discussed in this session. We have learned the definition of alternator, and we have learned the basic principle of working of alternator, and we have seen some of the likely to be asked questions or multiple choice questions based on this session. So this is the reference books once again, and this is the LMS state team of this subject 15EE31T, that is the DC machines and alternators. Thank you, dear students. Hope you have enjoyed the learning management system. Thank you, one and all.